Hope you
Good
get the
morning, Oliver. Thank you for joining us today. I noticed on your LinkedIn profile that your education started at BCIT actually, before moving on to the University of Waterloo, where you received a bachelor's degree in civil and then a master's degree in civil and materials engineering. So we're back on home turf, so to speak, or at least virtually.
That's right. Yes.
The
It was a good time I had at BCIT, and it was a good stepping stone to move on to Waterloo. So, and there's quite a few people I think that kind of followed the same path that I've crossed through the last few years too.
it's interesting. I've started to notice that a lot of people in technical industries actually did start some form, whether the beginning of their schooling career or the end of their schooling career actually did land at BCIT. It's sort of
Yes,
this.
that's right.
Um, Speaking a little bit about, or maybe you can introduce yourself a little bit and what you do currently and a little bit of sort of the path you've taken to where you are now.
Sure. Yeah. So currently I am a senior materials engineer with WSP. I've started my career with Levelton. I was there for 15 years, got acquired by WSP in the process. And then I joined Wood actually about a year and a half ago and got reacquired by WSP. I've changed, my path kind of changed initially from primarily technical role, project management, but typically managing smaller projects and more being involved on the technical side. Big portion of that was actually more on the structural rehabilitation, old structures, and then got into working on new construction projects in terms of materials aspects, service life. I moved to Alberta for about 10 years, where I was in a management role, looking after materials, geotechnical environment business for about up to 40 people, and then reverted back to a technical role when I moved back to the coast here, and kind of had a combination of managing small teams, managing smaller projects, some of the larger contracts with Ministry of Transportation. And so my day-to-day work is a good mix. When I first started out, with probably 90% was in the field, 10% in the office, and now it's probably about 80% in the office, preparing reports, reviewing reports, with a big chunk of like 20% always like field work that I still get out there quite a bit, field reviews, some forensic work comes into play as well on some of the older structures, or even some lot of it actually, which kind of ties in the QA QC, is some litigation where we have failures in new construction or even rehabilitation work, and we have to find out what went wrong. So that's where the quality management aspect comes into play. So fair amount of the work kind of always ties into the quality of the work. A lot of work. I prefer being on the QA side of things rather than QC. It's I think it's a little more rewarding than doing just the QC, which really is then pigeonholed into the testing side of things primarily. So yeah, so I don't really have a typical day to day. It seems to change quite a bit in consulting. I think that's been the most rewarding part, that it's never the same every day. Yes, you have a week where you do just write a report, but it changes quite a bit because of the variety of projects. And I've been on some larger projects, but always just a small portion. So I'm not necessarily from start to finish on like a Port Mann Highway one. It's often on the early stages and then on the closeout portion, but I'm not looking after the overall managing the behemoth of the projects. It's usually smaller portions of that.
You mentioned quality assurance and quality control, and this is something that we actually talked about in yesterday's class, and kind of trying to really differentiate between the two. Often the trades are responsible for quality control, but of course there is a check required by a general contractor, and then the consultant, as an inspection, in the inspection way, you do get involved in the quality control, right? But then you did talk about quality assurance. Can you just talk about, maybe some specific tasks or specific activities you would do in each of those categories?
Yeah, I mean, on the quality control side, usually if we get involved, we work for the contractor. In many cases, the scope is fairly clearly defined to quality control testing. So be it concrete testing, that's kind of the most common one, compaction testing, in place density, aggregate testing, depending if it's civil works. For buildings or bridges, it's often just the concrete testing. The scope sometimes expands on that throughout the project in terms of doing some specialty testing, be it thermal monitoring for mass concrete. But it's pretty much following the quality control plan that's been prepared either by the contractor or somebody else. In some cases, we prepare the quality control plan for the contractor. I usually don't get too much involved in preparing the plan, but provide input on that. And then the quality assurance side, usually we get involved on the owner's side, depending if it's, could be the ministry. If it's a P3, we might be working with the financing company, and then it's becomes more involved on actually, in some cases, an audit type role, reviewing documents, review of submittals. So on the QC side, often we're involved in submitting a lot of the documents required. On the QA side, it's often reviewing RFIs, non-conformance reports, concrete mix designs, constructability, reviewing actually the quality management plan that the contractor has to submit. So those are for the larger projects. Where it becomes a little cloudy is a lot of the smaller projects, where in many cases we do a QA role, but we actually do the QC testing because there's only one party involved doing the testing. On larger projects, usually QA may or may not do testing. In some cases, in the old days, I think you did like 10% of QC was your QA test, but nowadays there are some projects where you don't do any testing unless you have to, there's some non-conformances you have to do coring and find out. But in many cases, the QA side of things can just be an audit role, reviewing a lot of documents and paperwork, making sure that actually the QC process is implemented and that the contractor follows the QC requirements of the project. So it could be, get involved on either side of those. And then generally, as a project develops, a lot of times there's more technical aspects to rectifying things. If there is NCRs, how do we fix things? So
can we talk a little bit more about an NCR? And I don't know if you're able to share sort of one particular example. We've been talking about it in class. I think a lot of people weren't aware of what an NCR was, how it differentiated from a deficiency, and how it would kind of go through the path.
I mean, one of the NCR example could be, for example, mass concrete becoming to play. If you have mass concrete being defined, if you have your least dimension is larger than 1 meter for concrete, that is, you have to have it's considered mass concrete. You have to manage the temperatures within the concrete because you can run into issues in terms of thermal cracking. So if you're exceeding the limits set out by CSA, say, be it it's 20 degrees differential and a maximum of 70 degrees. Sometimes project specs might be more stringent, but you have an exceedance on the project where any of those limits are exceeded. The contractor monitors it. They submit a non-conformance saying we've exceeded the temperatures. Now, concrete test reports still might turn out just fine, but it doesn't meet the requirements in terms of temperature limits. And then as part of the NCR, it usually goes, if we are on the owner's side, we would look at the NCR and then ask the contractor, depending on how the contract is set up, we would ask the contractor to come up with a remediation or a proposal on what they propose to do to rectify the situation. In some cases, it could be a do nothing. If they can justify that, then we would review it. In most cases, it stays with the contractor to come up with that, and then we would review and say, yes, it's okay, or it is not. And depending on the severity, it could be, in some cases, you may have repairs, you may have remove and replace if there's a long-term durability issue. So so that's kind of an NCR where you're exceeding a limit, essentially, where deficiency is if you kind of have a bad surface finish, I guess, if you want to call it that. So
that's helpful, and thanks for the example. That's one I hadn't come up with. We've talked a lot about concrete. I know you are a materials engineer, and obviously civil and materials is a lot of concrete.
yes.
Other materials you've come across or that you work with?
I mean, I do work, in some cases it's how to protect the concrete. So coatings and materials come into play, and how to repair concrete, any kind of epoxies, that kind of thing. I do get involved a little bit on timber on the assessment side of things and repairs, not so much on the design side, just I don't have the background for that. Same with steel, like my colleagues, there are metallurgists, they actually true materials engineers, if you want to call it that. They address like welding, inspection, coating. We have NACE certified inspectors. So I do get involved in somewhat of the assessment, but would have somebody else working with me on some of the remediation, or if it's specification for new steel. Like sometimes we get involved in doing actual tensile testing on reinforcing steel. We remove samples from structures, or we take samples at parts, similar to concrete testing. You take a sample to the lab and test it. So that comes into play for steel. So mostly it's concrete. We do earthworks, although I stay away from the aggregate side of things, is other than in terms of the concrete, but like soils and compaction and those things. We do get involved on the QC side, but I know mostly it's geotechnical engineers that look after any issues that come to light on that. A little bit of asphalt work, but again, I'm not a specialist on that, but it kind of ties in on the material side of things as well.
It's interesting, there's been a lot of innovation in concrete in the last few years. I mean, some of it's mixed design. A lot of it, we're trying to do this decarbonization, so we're shifting our mixed designs. Are you seeing any impacts of that on the quality of concrete?
Well, I think overall the quality of the concrete has gotten better over the years with all the technologies. We can do different things. I mean, the biggest one, like when I started, was the requirement just for service life, which kind of ties in with now the decarbonization of concrete. Part of it, the longer we can make structure last, the better it is for the environment. So, the service life and life cycle cost analysis was kind of the precursor, but now we're actually looking into what kind of materials we are using. And then, the initial one also in terms of decarbonization, it probably was more as a byproduct, was using high volume fly ash in concrete, because fly ash is a waste product, although the problem now has become that we no longer have access to fly ash because obviously coal-fired power plants are being shut down. So we're looking for new ways. So one of the ways is now they're reducing this limestone cement is coming into play a lot more. With all the admixtures, we can do a lot more in terms of accelerated set times. We have self-compacting or self-consolidating concrete, which has become a big benefit if we have to place architectural concrete, or it's for placement. It's become a big advantage. You don't have to do the whole vibrating. So there's a lot more. We can have much higher concrete strength, and there's new technologies now that get 100 MPa concretes you can design without reinforcing steel. You get some ductile properties as well, fibers coming into play. So there's been a lot, but I think the most recent one is definitely the greenhouse gas emission. There's a big push on the cement industry to reduce the emissions. So we're looking for alternative. Slag is another material that's never been available in BC. It's being used now, and for thermal control, these originally thought of waste products actually make a much better concrete. We can control thermal, we can control it for durability in terms of chloride penetration. So I think we can build a lot more durable structures than we used to in the past. Having said that, it also sets us up for a lot of times we end up with a mix that may not behave as simple as we had it in the past. It was just, you need a certain compressor strength and that was it. So there's a lot more, there's a big push towards performance-based requirements, with a lot of the public agencies like ministries playing a little bit of catch up on that, because they like to provide a recipe on how to do things, whereas now with performance-based, if it's done properly, I think you get a much better product.
That's interesting though, because of course, performance-based, the contractor is taking on the risk of essentially using a recipe to try and hit a performance spec. So if it doesn't hit that performance, it's a non-conforming item. Is that correct?
That's right. But I think, this is where I think the materials engineering side comes into play. Performance has to be defined. I think that's where specifications have to be written. What do we expect in terms of performance? I mean, it has to be achievable, but it's compressive strength is one item, but then we have to look at shrinkage, we have to look at chloride penetration, now greenhouse gas emissions. We have to factor in how much does a certain mix design produce in terms of greenhouse gas emissions. And part of that is it requires the contractor to do planning ahead on a project and then demonstrate to the owners that, okay, this is what we've done in terms of this mix can achieve these properties, and we can do this throughout production. It's where it kind of goes off the rails in many cases, is that they start a project and they don't plan ahead. It takes 28 days to get some initial results. So it takes planning. Okay, we have to do trials, or we have to look at, has the supplier used this particular product? Has it achieved that performance on previous projects? And if not, what do we have to do to change it? But it leaves, it's more risk for the contractor, but also they can, be cost savings in there if they are, spending some money in terms of developing a concrete mix design that they need for the project. But in many cases, they're trying to achieve the performance based on, oh, that's how we've done it in the past. And that's where the performance-based specs in many cases fall flat. So.
Yeah, no, that's helpful. That's interesting. It's interesting that you say that. We talked about, you sort of mentioned innovations, and maybe we've covered this in terms of the concrete. You talked about the different fibers and different things that can be in the mixes. Are there any other innovations, whether in the material itself or actually in the testing practices, that have really impacted your job, and whether it's the quality assurance or the quality control?
I think in terms of the materials, it's the newer, cementitious materials coming online, limestone cement. How does it behave if we're having sulfate exposure? We have to address that. Geopolymer cements are becoming more and more popular now. Well, I wouldn't say popular, but they're in the development, so they want to implement those. I don't have a lot of experience with them particular, but they're different from just like a Portland cement. They're more environmentally friendly to manufacture. So admixtures are constantly evolving that come into play. And then the tricky part is, and one example that you kind of can look at is epoxy coated rebar. So with all these new materials, they behave in a certain way when we do all the testing, but how do they work over a 30, 40, 75, 100 year service life? Epoxy coated rebar was touted as the be all and end all, and we all know it didn't quite pan out. It doesn't give us that extra service life that we were looking for. So, part of that is it's kind of all slowly evolving and taking the good things, and then, okay, what doesn't work, we have to look at that. And I think in terms of testing methodologies, we still do our basic concrete testing, but there's been a lot of development where we can look at non-destructive methods in the long term in assessing concrete. It's always, you can't just use non-destructive without some destructive, but you can actually get a bit of a picture in terms of corrosion, what a corrosion, assess corrosion rates, not just do half cell. Verifying, like in terms of service life, we say this is our chloride penetration rate, and then go back to these structures and actually monitor it early on. I think that's one of the things that's coming with a lot of P3s, where they have to start at day one basically to do annual changes, because in many cases we look at bridges that are 20 years old, they're having issues, but if we can actually, a lot of that is now being done year 1, 2, 3, so we get a history and what is changing, so it can be addressed. We have cracking, we can fix it early on rather than later on. Another big one, as I mentioned, is mass concrete is now in, it wasn't in CSA, I think it was the last iteration of A23.1 where mass concrete had to be addressed in terms of thermal limits, because there are problems with cracking. So we can actually model it and then monitor it as part of the construction process. Maturity testing has become a big one in terms of advancing construction at a certain rate, post-tensioning. Field cures don't really work, so maturity testing is a big one where we can predict how a concrete develops strength over time. So there's a big one, rather than just breaking cylinders. If you, again, it comes back, you have to do it at the onset of the project. You can't all of a sudden, oh, we're going to do maturity testing tomorrow. It has to be planned out for the specific mix design that's being used. So some of those technologies, it's become I think the industry is becoming aware it's not just slump, air, and compressive strength at the end of the day. There's a lot more that has to be looked at, alkali aggregate reactivity, and that's been known for quite some time, but making sure that the aggregate sources are tested beforehand. It's a lot easier if you do these things in the city. If you go to remote areas, you don't have all these technologies available. There's simple batch plans. The materials aren't necessarily going through the same QC process. So
it's interesting you say that, and I want to sort of close out on one final question, and I think you've kind of touched on it many times. You've touched on plan and adjust, right? We sort of do the
yeah,
plan, do, check, adjust, and I think years ago it was a little bit more do and check, do,
yes,
check. And I think what I'm hearing from you is now we're really focusing on planning, so really know all the QA and QC you're going to do ahead of time, design it in, and then adjust. And I want to drill in on that one a little bit, because I know you do both forensics and you do sort of front end planning. Is there an example or something you can share with us where you really looped in the adjust into the planning?
I think we have some of the projects where we are involved. Actually, Okanagan Lake Bridge or W.R. Bennett Bridge is one example where it was all planned in terms of service life and what are the expectations, but then we found, or the design build team found there was a fair amount of cracking in the deck, so they had to address it within year one and do a fair amount of crack sealing and crack repairs in the deck, because they didn't expect some of those. I think most of the cracks were due to restraint, the way it was designed, and it's being a floating bridge. So those are some of the items. Thermal, again, have to kind of harp on that one, but that's a lot of times where we have to adjust because things may change, section sizes, or the thermal control plan wasn't really thought through from the beginning, or the mix behaves different, or the weather. Oftentimes you plan on placing concrete in the winter, but then now you have to do it in the summertime, and you still have to meet the thermal requirements, so that it's often comes into play of this, or in many cases the contractor might one actually I didn't mention earlier is, for example, is structural shotcrete has become a lot more popular for parquet walls primarily, instead of doing regular formwork. So the design was laid out as a basically form and pour, and then contractor proposes we want to do structural shotcrete. So you have to adjust, to some extent. Your quality control is completely different, because now you have to do shotcrete panels. You got to make sure that they have certified nozzlemen and all those things in place. So that's where you then adjust. There's often, especially on P3s, there's a lot of design changes. Contractors come in, okay, let's try something different. Portman was another example where they slip formed the main pylons for the Portman Bridge. And I believe the Canadian Bridge Code does not allow for slip forming of bridge pylons. It might now. I'm not an expert on structural engineering, but I required them to do full-size mock-ups to demonstrate to do the slip forming. I mean, it's been done in other countries, but just because there was not a lot of precedents in Canada to do the slip forming for that. So doing full-size mock-up, that would be another one where the design originally was for doing jump forming. So a lot of it comes with the innovation, with the contractors getting these performance targets they have to achieve. They're coming up with innovative methods, and a lot of the contractors are they're well ahead of some of the agencies like MOTI in terms of what they do on an international scale. They want to bring it to a local. We want to do this, so that's when the owner's team has to adjust. Can we do this? And in most cases it works out. You just have to change sometimes your expectations.
That's great. That's actually a really interesting example. So often we think that what the owner asks for is exactly what you have to do. And I think what you're saying here is when the owner asks for performance, you have a lot more freedom, and that's really what drives innovation.
That's right. And I think that's a big one with, P3s gets mixed reviews and on how they work and the financing, but I think a lot of they do drive innovation, because the contractors they want to make a profit at the end of the day, but they also want to they're responsible for whatever the concession period is. So it's not like they can just build it and walk away from it. They have to maintain those structures. So I think it does leave it open for a lot of innovations. I mean, you could bring in international experience, which you wouldn't have if you just do a regular design bid build type approach.
Well, thanks, Oliver. I'm going to stop the recording now, but thank you so much for sharing that with us.
Yep, anytime. I hope I didn't ramble on too much.
That was super interesting.
I wouldn't go that far.